Hi everyone. So today we're going to work on multiplying radical expressions. So we're going to want to be able to multiply the radicals together and then break them down so that they're like factored or simplified. All right, so we're going to multiply radical expressions and then we're going to simplify them by using factoring. Now factoring meaning number factoring, not quadratic factoring. Well, some quadratic factoring. All right, so let's take a look at what I mean by this. So let's say we have the square root of 4 and the square root of 25. Well, the square root of 4 is 2, the square root of 25 is 5, and I'm multiplying these together, we're going to get 10. But if we take the square root of 4 and the square root of 25 and multiply them together, we get the square root of 100, which is also 10, which means that we can simplify first and multiply, or multiply and then simplify. If they're perfects, that's great. We can simplify first and then multiply. But if they're not perfects, perfect meaning a perfect square, a perfect cube, a perfect fourth, then we're going to have to do some work. And keeping in mind that our product rule basically says that you can multiply nth root of a times the nth root of b, get the nth root of ab. They have to have the same root. Okay, you cannot multiply the square root of 5 with the cube root of 4. We're not allowed to do that unless you make them fractional exponents, okay? But that's still not going to work because they're not the same base. So it just doesn't work. Okay. All right, so let's say we want to multiply the square root of 2 and the square root of 7. So according to our rule, we're allowed to multiply them together. So we get the square root of 14, and that's it. Okay. So let's multiply these together. So we get x plus 3 times x minus 3. And when we multiply those together, we get the x squared minus 9. And by the way, okay, you are not allowed to separate that. The square root of x squared minus the square root of 9 from the square root of x squared minus 9. Nope. The answer is not x minus 3. Nope. Can't do that. Cannot separate by addition or subtraction. Only multiplication and division are we allowed to do that. Okay, so let's come over here. Since they're both fourth roots, we can multiply them together, and we get 7y over 5x. Okay, and 4, we're going to multiply straight across. We get cube root of 20, and that's it. All right, so you are allowed to multiply radicals that are the same, and you multiply the numbers underneath. And from there, we're going to see if we're going to be able to simplify some. Okay? All right, so when we simplify by factoring, we're basically going to break down the radical into what I would call a perfect factor times a non-perfect factor. Okay, what I mean by perfect, I mean a perfect square, a perfect cube, perfect fourth. Non-perfect would be like the square root of 2, something that we can't break it down. Okay? All right, so nth root of AB means that I can take the nth root of A times the nth root of B. So basically backwards. Okay, so I can multiply, but then I can also separate. Okay. So I can separate the square root of 20 to the square root of 4 and the square root of 5. Square root of 4 is 2. So the square root of 20 can be simplified to 2 square roots of 5. Okay? All right, now I have a list here of like possible express the radicand as a product in which one or more of the factors are perfect. Write the expression as the nth root of each of the factors. Simplify any expressions containing the perfects. And here's the thing. We know we're done when the factor that is written of the perfect n power, all the factors in the radicand can be written with exponents that are less than the index. So if you have the square root of x to the 4th, you're not done, okay? The root always has to be bigger than the exponent underneath. Okay, now, the biggest problem people have is finding that perfect factor. So I use factor trees to find the perfects. Okay, so for example, here's 200. I'm going to break 200 down. And I'm looking for a perfect factor. So I'm going to look for when I have perfect, meaning square root, perfect square multiplied by itself. So to me, 100 is a perfect square because it's 10 times 10. So we can break 200 down into 100 times 2, and then the square root of 100 is 10 square root of 2. Okay. So I use factor trees to help me find my perfects. So let's try square root of 50 x squared y. So I'm going to take 50 and break him down. I'm going to do 2 and 25. And 25 is a perfect because it's 5 times 5. So here's my perfect. So we got 25. And then 2 doesn't have any, 2 is not the perfect. Now let's talk about the variable, x squared. So x is squared is x times x. Now remember, we're doing a square root, so a number times itself. He is a perfect. Now y, it's square root of y. Can't do anything with him, can't break him down. So I'm going to be able to take the square root of 25. I'm going to be able to take the square root of x squared. And then 2y is going to stay underneath the radical sign because he's not perfect. All right, let's come over here. Negative 72. Okay, so I'm going to break down negative 72. Negative 9 and 8. So he's negative 3 and negative 3, or 3. 8 is 2 and 4, and 2 and 2. So remember, we're looking for a perfect cube. So here's my group of 3, as I would say, or my perfect. So I got the cube root of 8. Cube root of negative 9, 2 cube roots of negative 9. Now, you can put the negative with the 8 and make this negative 2 cube roots of 9, and that's perfectly okay as well. All right, let's do 162. Now, I don't know about 162, so I'm just going to divide him by 2 to start with. 81. 81 is 9 and 9. That's a perfect square. But if I break it down further, here's my perfect fourth, right? Because it's multiplied by itself 4 times, and I'm looking for a perfect fourth. So 81 is a perfect fourth. And then the 4th root of 2. Okay, so let's talk about x to the 6th. Okay, there are 6 x's. Now, x to the 6th means that I would want a number multiplied. I'm looking for a group of 4, right? Because it's a 4th root. So I want a group of 4. Those are perfect. And then I have 2 that are not. Okay. So 4th root of 81 is 3. 4th root of x to the 4th is x. And what I have left is 2x squared. And I'm good because x squared is smaller than 4. 4 is bigger than 2. Okay. All right, let's try some more. So here we're going to have to factor. So I'm going to take a 3 out first. And it just so happens that x squared minus 2x plus 1 is a perfect square. Okay? So I can break this down in the square root of 3 is square root of x minus 1 quantity squared, which we know is a perfect. So we get x minus 1 square root of 3. Now we're going to put those in absolute values because I don't know if that's a positive number or not. Okay, so let's do the same thing over here. I'm going to take out a 10. Can we go higher? Nope, just 10. Oh, that's a perfect as well. Okay, so we're going to bring that out. It's x plus 3. I'm going to put it in absolute values because can't guarantee it's positive. Square root of 10. I probably should have put the other ones in absolute values. All right, let's come over here. All right, now I have 7 x's, 11 y's, and 9 z's. Okay, so x to the 7th is 7 x's. Okay, now I want the highest number of perfects. So here's a perfect, x times x. Here's another perfect, and here's another perfect. So x to the 6th and x. Let's do y to the 11th. That's 11 y's. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I want square root, so I want 2 of them. So here's 1, 2, 3, 4, 5. So x to the 10th, or y to the 10th, excuse me. Y to the 10th and y. Square root, square root. Z to the 9th. There's got to be a better way. Let's see if we can come up with a better way. 2, 3, 4, 5, 6, 7, 8, 9. Okay, pair, 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 pair. So I get z to the 8th and z. Okay, so z to the 6th square root would be x cubed, square root of x. Let's move this over. Y to the 5th, y. Z to the 4th, z. Okay, so here's what I notice. That's a square root, right? 2 divided into 7 is 6 with 1 left over. Square root of 6, no, 2 divided into 7 is 3 with 1 left over. 2 into 11 is 5 with 1 left over. 2 divided into 9 is 4 with 1 left over. Aha, so I think we can do this. So you're going to take the index, the root, divide it into the exponent. That's going to tell you the perfect, and then whatever the remainder is goes underneath the radical. Let's see if that works. Okay, so I'm going to do my 16. Okay, so here's my perfect. 2, 2, 2, which is 8. Cube root of 8, cube root of 2. Okay, so now I'm going to go 3 into 7 is, what is that? Twice with 1 left over. No. Yeah, 3 into 7 is twice with 1 left over. 3 goes into 14 4 times with 2 left over. This is cube root. Yes. Okay. So cube root of 8 is 2. Get x squared b to the 4th. That's a squared. Why did I write x? And then we have the cube root of 2, a, and then that's b. Why did I write 2? This is b squared. B squared. Okay, and we're good because 2 is not a perfect cube. A to the 1st is smaller than, the exponent of a is smaller than 3, and the exponent of b is smaller than 3. So that's how we're good. So, shortcut. Divide the root into the exponent. How many times it goes in evenly, it comes out, left over stays underneath. Okay, so multiplying and simplifying. Sorry, this one went a little longer. What I do is I multiply first, then simplify. Okay, so I'm going to multiply these two together. Square root of 90. Break that down. Okay, 9's a perfect square, so we're going to go to the square root of 9. Square root of 10 is 3 square roots of 10. And 10, even though it's a nice even number, its factors are 2 and 5. Those are prime, so there's no perfects in there. Okay, so we're going to multiply the numbers. Cube root of 125. 125 is a perfect cube. 30. Okay, so multiply our numbers. Add our exponents. Okay, so 32. Remember now, this is a perfect fourth we're looking for. Oh, here's our perfect fourth. There's 4 2's. So 16's our perfect fourth. So we're going to get the fourth root of 16. Okay, 4 goes into 5 once. Oh, hang on. I forgot the 2. Fourth root of 2. Okay, so 4 goes into 5 once with 1 left over. 4 goes into 8 twice. None left over. So 4th root of 16 is 2. We have an x. We have a y squared. 4th root of 2x. Okay, let's try one more. We're going to multiply these two together. Get the square root of 150x squared. 150. I'm just going to use 10 and 15. Okay, so here's my perfect, is going to be 5 and 5 is 25. That's my perfect. And then notice that I have a 2 and a 3. They have to go together, so that's the square root of 6. This is a 2, so 2 goes into 2 once. 5x square root of 6. All right, guys, let me know if you have any questions. I'll talk to you again soon, and stay safe out there, okay?